So I get to introduce myself and start off. It is on top of the hour, so we'll get started. Today, we're going to talk about the importance of exactly once semantics for your analytic processing in relation to Apache Kafka and Apache Druid. I am Neil Busing. I'm a principal solution architect at Real Data. We provide a SaaS stream-based offering of Druid for your analytical data processing, and we use Kafka for our real-time ingestion into that platform. If you're interested, you can follow me or reach out to me through either my Twitter handle or LinkedIn handle as well. To get started, I'm going to talk about the takeaways, things that I hope that you learn from this session or you can benefit from in that. Basically, grading card to see if I succeed at covering the things that I hope to set out to talk about. We're going to go over Apache Kafka. We're going to discuss an overview of its architecture, primarily around exactly once semantics. We're going to go into Apache Druid and look at the Kafka ingestion piece of that platform and focusing on how it creates itself as a Kafka client consumer and using read-committed transaction isolation level. We're going to look at them together, how they actually achieve exactly once by what they both do and what they don't do. I'm going to walk through a prototype, an example demonstration that will be also provided to you in a link that you can try out yourself if you so desire. We'll look at some of the settings around Kafka Streams and some of the KSQL DB specifics along the way. First, let's start and talk about Apache Kafka. The Kafka ecosystem in general is nothing more than a set of brokers with disks for getting that data in and data out. And a lot of the nuances of Kafka is put into the Kafka client libraries. And you have the producers and consumers doing that work for you. Those client libraries can be used directly, as I said, with a producer or consumer, or you can use them through Kafka Connect and leverage pre-built configurations that are producers and consumers that can be configured to serve a certain function, such as reading from a database, writing to a file system, writing to a database, or writing to a specific database such as Apache Druid. Then there is Kafka Streams. Kafka Streams is the analytic processing, the enrichment, the transformation piece of the ecosystem. It is where you read data from Kafka, enrich it, store state, and write it back to Kafka for further processing. Kafka Streams uses Kafka itself for its durability and uses a RocksDB database for availability and for that real-time processing of that state. KSQL DB is a Kafka Streams application that is built on top of Kafka Streams. Everything on the screen here is Apache Kafka. KSQL DB is Confluent community source-driven project. So it is not part of the Apache ecosystem. And nothing from today requires the use of KSQL DB, but it's an excellent tool to show the benefits of Kafka Streams without having to write any code. So in Kafka, there is the basic concept of a topic. And a topic is what a producer writes to, and it's immutable. Once the producer writes to it, it's there until the broker decides that it needs to be discarded because you have too many messages or a certain period of time has elapsed, configured driven. Consumers read from that topic and they read independently of the producer. Producer doesn't care where they're at. Producer doesn't need to know. You can spin up as many consumers as you want, and consumers can subscribe or assign themselves to a topic to do work on it. When you subscribe, consumers work together to read a topic, and the client library is responsible to divvy up the work between them. When the assignment's done, the user of the client library is taking on that responsibility. Another aspect of subscribe that's typically used is the consumer offsets are then also maintained within Kafka. When you look at this from a topic standpoint, there's not a lot there. It gets more important when you start looking at partitioning. In partitioning, you have the producer writing to a topic, and it can go to multiple brokers in order to get more throughput through the system. And then consumers can read from each of those partitions. And consumers in a group, if they subscribe, will determine who gets what partition, and the client library will take care of that. If you have 2 partitions, you can have 2 consumers. If you had a third, it would just sit idle. If you had 10 partitions, you could have 1 all the way up to 10, and the library is taking care of allocation of that work. Consumer A here is deciding to read from both partitions because there's only 1 instance of it running. Consumer B has 2. And then the subscription is writing those offsets to Kafka to maintain where they are in reading those partitions. The key here really is Kafka preserves ordering by partition. So as long as I only allow 1 consumer to read from 1 partition, then I can preserve order in that specific partition. And then Kafka allows me to only put certain data to a given partition. So I can say all orders from Neil, because I key by that, will go to partition 1, and I can make sure they're ordered. Now, what happens when it comes to transactions? When you bring in transactions, remember, producers are writing to immutable log. If they write to one and they can't write to the other, you still have that data preserved on a topic or a partition of that topic. So with transactions, Kafka in 0.11 introduced a transactional log that helps the producer say when it is done writing to those topics. And then the consumers can read from those partitions. And if the consumer says, I can only read committed messages, it will not get messages back that were marked as aborted or never finished or currently are being processed as part of a transaction. This will be important in how we relate exactly once semantics of Apache Kafka and how that ties into Druid. So quick overview of Kafka, and we're focusing on exactly once semantics. So what doesn't exactly once semantics do for you, I think, is the key to understanding how Kafka does transactions. There is no processing of dedupe messages from the producer. If your client code writes duplicate messages, that's on you. EOS is not going to remove them for you. If you're pulling a connect from a source system that's creating duplicates, again, EOS is not a deduping process from your business logic. You create duplicates, you're going to have duplicates. That's, again, on the source system or your code. It does not interact in any 2-phase commit operations. So you cannot tie Kafka writing of where it's written or read from with those consumer offsets to what you're interacting with. So there's no, I want to write to a database, and then I also want to make sure those offsets match what I wrote in a database. This is key because what Apache Druid does is how exactly once semantics actually blends these 2 technologies together. There is no transaction between Kafka clusters, and there actually is no exactly once semantics with Kafka Connect yet. There is a KIP, and KIP is Kafka's improvement proposal that is working toward allowing exactly once semantics with Kafka Connect. And then there is Mirror Maker, which is a replicating tool that's also built on Kafka Connect. And there is another KIP to get exactly once semantics into that technology. So this is what EOS doesn't do today. The piece around Connect and Mirror Maker may be coming or will be coming as those KIPs get implemented. So what does exactly once semantic does for you? It allows producer to produce a bunch of messages and either commit them or abort them as a single unit of work. And additionally, it allows the keeping track of where you consume from, that is those offsets that the consumers are reading, to be part of that transaction. And this is what Kafka Streams and KSQL DB does so well, is because it's handling all of this for you. So therefore, you can read a message, produce a message, commit the offsets of the messages you read, as a single unit of work, allowing that stateful processing within Kafka streams to be ensured to be done atomically. And if there was an issue with that processing, the transaction would roll back. Those markers would never be written. Those consumer offsets wouldn't be associated to where the markers were committed. The application starts back up. It would start back up to the last recorded offsets. And anything that it may have written won't be utilized. So in addition to Kafka producers and consumers having this transactional layer available to it, there is the extra work that Kafka Stream does to ensure that the stateful processing that it is doing is also part of that transaction. As I mentioned earlier, Kafka Streams uses RocksDB for the availability of the state that it is performing. So if you're aggregating data, you're joining data, you're enriching the data, and you need to preserve that state, that is done in Rocks. And it's a key value store, and it can be done very quickly. However, if the application dies, you lose that disk, where is that data pulled from? Well, that's where Kafka Streams puts into changelog topics. These are compacted topics in Kafka where only the last value is kept. And if Kafka Streams app has to restart from the beginning because the disks were destroyed and has to rebuild that state, it will read up all those changelog topics. And because those can be part of the same transaction as the producing and consuming, you now have that transactional guarantee within Kafka Streams. The other thing that Kafka Streams does for you is it creates the producers and the consumers of Kafka behind any of the coding that you have to write. One of the nuances around building producers for transactions with Kafka is you have to have a separate transaction ID, separate instances of producers per thread or per unit of work that may be happening currently within the application. Without exactly once, Kafka could create one producer, a large buffer, use that across all the operations that are being produced within that streaming app. With exactly one semantics, they have to be isolated from each other. Kafka Streams does that for you. You don't have to worry about it. So if you're leveraging the API or the DSL of Kafka Streams, there's nothing you have to see or worry about. There are some settings within Kafka Streams that you may want to worry about. Typically, if you have an aggregate in Kafka Streams, the commit interval is 30 seconds under at least once. With exactly one semantics, it's 100 milliseconds. If you change that, you have to worry about the transaction timeout, which is 10 seconds. Normally, you don't have to worry about it, but they're there if you do. If you have to tweak things, it's available to you. And remember, anything that I talk about in Kafka or in KSQLDB, as far as tuning configuration, applies here because it is a Kafka Streams application. So there's Kafka. There's a quick overview of that. Now let's talk Druid and what Druid does that makes exactly one semantics of Kafka work in our analytical database. So Druid has a Kafka consumer. There's two things that Druid did that makes this work so well. The first thing that it decided to do was it uses assignment, not subscription, to manage where it is reading from in Kafka. So a Kafka supervisor will spin up as many tasks as you tell it to or partitions that are within that topic. For ease of demonstration here, I had 2 partitions. I spin up 2 tasks. Now, there is going to be no shuffling of work between subscribing. If they had subscribed, the client library is going to decide who gets what partitions. And if it thinks one is not available, it's going to potentially assign that other partition to the other task that's running. That wouldn't work well for writing to segments within Druid. You would potentially duplicate data between segments or have uneven segments, a variety of aspects that could go wrong. So Druid says, we're going to manage all of this ourselves. The other thing that Druid does and does well is it says, Kafka, you don't worry about the offsets. If I have to restart a segment because a task died or something else went wrong, let the supervisor recreate that task and use the offsets that are stored within Druid to tell it where to start up from. What does this give us? This does give us, in essence, a two-phase commit by leveraging Druid for those offsets. So if I can't write to the segment, I don't write the offsets to Druid as well. And if I can write the segment, I do write the offsets within Druid. So the consumer has that durability of knowing where it last was successful. So if something dramatically goes wrong, it will restart from the correct spot. The other thing that Druid does is it says, I'm going to consume with the isolation level of read committed. Read committed tells the Kafka client library, do not read committed messages, does not read transactional messages that do not have a commit marker. So if a transaction marker of aborted is associated with that message, it's never read and provided to Druid. The client takes care of that. The broker takes care of that. If there is a transaction in process, that never gets returned because it may be aborted. Or if there is no markers at all and the timeout occurred, those messages would not be provided back from the Kafka client library to Druid. What could be the downside of doing this is it's going to have to wait for transactions to commit. So if someone's taking a long time producing transactional messages, increases that transaction timeout, you may get a delay into Druid. And then end-to-end latency as a result of that may increase as well. So why does Druid do this? Well, again, as I mentioned from that initial diagram, it's to give us that two-phase commit of what was I successful in writing to the segment within Druid that I want to make available to the users of the database in real time, and where do I keep track of where do I keep track of the metadata I need on a disaster scenario? A segment crashes, a task dies. How do I know that I can resume from where I left off? Druid is not an idempotent database. If I write the same record multiple times, I'm going to have multiple records in the database or incorrect roll-ups as a result. So it's important to have this. And this is why what Druid did works so well with Apache Kafka. Druid isn't the only one to have done this, but it is one of the early ones, and it has done this for a long time and it's well tested. The isolation setting is on by default. If you're working with a topic that doesn't have transactions, it's not going to change anything. It's not going to wait for markers because each message tells the client if it's part of a transaction or not. And there are other systems that do it. And even those that are part of the Kafka sync connector system, such as Kafka Connect HDFS, which will write the offsets, the partitions and the offsets to the file system of HDFS. So if there's an issue with the connector says, the offsets that are stored in Kafka, I'm not going to use those unless I have to. So it goes and gets it from the HDFS file names or some of the other metadata it may store and lets that be the deciding factor on where it should resume. Here's a little insight on how Druid is storing this data. In the Postgres database, there is a Druid data source table. And for each supervised set of tasks, you're going to get the partitions and the current offsets in a JSON representation. So if you're debugging, you're trying to figure out what's going on, you can go into the database, look at this yourself to know that it's working correctly. Then to go back to where we started, here's the Kafka consumer. Again, the supervisor is doing assignment. Those offsets are in Druid. The segments are in Druid. Everything's working with the transactions of Kafka because Druid is taking care of those aspects with the database in regards to where it is read. So we're going to walk through a demonstration. We're going to watch what goes wrong, what goes right between configuring KSQL and configuring Druid in regards to exactly what semantics. So for this demonstration, I built an application through configuration. I have 3 Kafka Connect clusters, or 1 cluster, 3 workers. I have a data generator that generates random orders, and I tell it to create orders sequentially, and that's my control. I know that there should be a unique order in my system, no duplicates. I also create from a database or from a file a K table, which in Kafka Streams is like a key value table of stores and users. I use KSQLDB to enrich the data. We're building an analytical platform. I want to do analytics on stores and user data. Users has things I need in order to enrich the order. I'm going to use KSQLDB to do that. And then Druid, I'm going to push all that out. And for my control, I am storing the order numbers. Typically, order numbers for an analytical database may not be important. It increases the cardinality of rows in the database, or it doesn't allow for roll-ups because they're all unique. But for control, it's quite important. Here's the application again. In the code link that I'll provide at the end, under a demo section, EOS are all the scripts, if you're interested to run it. 1,000 users, 100 stores, incremental order numbers. I'm storing the order in Druid for my control. I build the connectors through the build script. I start up all the Docker containers for Kafka Connect, KSQL, Druid through the up script. The setup script creates those connectors, creates KSQL queries, creates the Kafka ingestion spec, and uploads that through the REST endpoint of Druid. Even though I use the UI to build it, I create it, I save it, and then I use the RESTful API to script it. And you can tear everything down. And there's even a script to kill KSQL nicely, not so nicely, upon your wishes. The heart of the application is this KSQLDB. It is, I'm joining the order with users, I'm joining the order with stores. I'm bringing in from the user reward. What reward system are they part of for getting benefits from this company? The quantity purchased is kept, the zip code of the store, the area code of the user. And then I highlighted in yellow some of the little nuggets I'm going to talk about that are useful from KSQLDB if that's something you decide to use yourself. Primarily, the important one is as value, because in KSQL, if something's part of the key, it doesn't put it into the value. And on a topic, the key goes into the key, the value would go into the message. Druid ingestion only reads from the message. So you have to duplicate that data so you can leverage it from Druid easily. We'll talk a little bit more about that at the end. It creates 4 internal topics. Changelog is the durability. The repartitioning is to allow for the joins to occur and be distributed. I need that to be transactional. KSQLDB, Kafka Streams under the covers will do that for you. Here's the test scenario we're going to go through. I'm going to enable exactly once on KSQL. I'm also going to force read on committed in Druid. I'm going to be nice and shut down the app. I'm going to be mean and kill the app. And we're going to look at Druid to see what's going on. Here's the query. You would see it in the fireside. No, it was in the keynote after, I think, covering the new features to come, that if you do aggregates on count or sum, it's a neat way to see what's being rolled up. Well, we're not really doing any roll-ups right now, but I still love the query of always keeping track of summing my count and counting my count, so I can always see what roll-ups are occurring in the database. This query, if I have a bug, is going to return a result. If I don't have a bug, it should return nothing, because I said in that data gen service that all orders are unique and they're only created once. So I'm looking for any orders that may have duplicated in my system for these fields. I'm also not looking at all the fields, just the order ID, in case something else went wrong. But it should cover it. So here's the state of that query before I stopped KSQLDB. Nothing's there, which is what I want. So then what did I do? I have KSQLDB at least once. I shut down KSQL nicely. This allows the producers to stop, the offsets to be written, the consumers then to be told when they start back up where to read from, and then I restarted KSQL. So this was a graceful shutdown. And lo and behold, I ran that query and I got no results, which is what I expected. And the reason I point this out is in a happy, perfectly set up environment, everything's going along fine, you've tested your system, you think you built it correctly, and then something happens a month later, 2 months later, and you wonder what's going on. So now I take care of this, and I'm going to tell KSQL, I'm going to kill -9u, so you don't have any time to write offsets on anything that you're currently processing, and I bring it back up. And lo and behold, I get duplicates. And that is because any topic that I had read for the, I think either 5 or 8 seconds in my configuration of committing interval offsets, I will have reprocessed them. So I'm getting duplicates as I would expect in building a system without exactly one semantics, because Druid is not idempotent, all those are getting replicated. Now I turn on exactly once in KSQLDB and I kill Druid, right? I kill KSQL and I start it back up. I am expecting and hoping that I'll get no results from my query. Here is the command that I wrote that's available to you. I do a kill, I do a restart. It goes in and does all that work for me. And lo and behold, everything looks good. And we'll go into the topics so you can see as well that everything went as expected. Then lastly, I am going to actually do exactly what we did before, but I'm going to tell Druid, don't use read committed, use read on committed. I'm going to kill it. I'm going to restart it. And sure enough, I get duplicates again. And this is the key, and this is the importance of what exactly one semantics is with Kafka and how it relates with Druid. You need both parts doing their need of not replicating data in order to be successful. If you look at a consumer console of those orders where I'm reading on committed, I will have the exact same order, timestamp, everything from KSQL in there as 2 different offsets. I'm reading both. When I turn on read committed, it's only returning the last one. This is exactly then what Druid is doing to ensure that any transactions that KSQLDB did, that Druid would also honor. The beauty of it is you don't have to do anything to get it because it's setting that by default for you. Some resources for you to look at if you are wanting to know more. When transactions were written for Apache Kafka, there's a 3-part blog series that's still very pertinent today. This is the link, as I've recently verified, is available to getting to that blog series. Personally, there was talk in the keynote about documentation like 5 years ago. The documentation is fabulous for Druid Kafka ingestion. It is everything that I needed to understand to ensure that I could test the system and set up the number of tasks that I wanted. All that is well defined. If you're looking to understand Druid ingestion using Kafka, go there. And then the best presentation I ever had on Kafka EOS that I have seen, that I always recommend, is Jason's talk from Strange Loop, I think 2017. So there may be a few things that have changed, but in reality, how difficult it was to build transaction and distributed system, it's an excellent watch. Highly recommend it. Let's go back to the takeaways. Let's see if I was indeed successful. At least I hope to. We covered Apache Kafka, the overview of its architecture, primarily focus around exactly once. You have some resources to dive into that more. And we looked at Kafka streams indirectly by using Kafka KSQLDB, not KSQLDB. We looked at Druid. We focused on Druid's ingestion of Kafka and how it relates to using offsets managed within Druid and what it happens if we didn't do that, as well as the commit consumer. And then through 3 test scenarios to see did it work or not work by turning on or off each of the switches on both sides. So you could see what was going wrong if we set up something wrong. Build a control so you can test your system. You may not want that control in your end system, but you're going to want that to verify that you've built this out. And by leveraging the exactly once of Kafka streams and the recommitted of Druid, you can get an exactly once analytical platform built with these 2 technologies. Just remember, EOS is only, from Kafka standpoint, is unique to within Kafka. So you need something being done by the other system to make it successful. Typically, when I sync to relational data models, I build systems that are idempotent, and I use upsert technology of the databases, merge in Oracle, and other nuances to make sure that I get that behavior. The extra nuggets, if you're going to use KSQLDB, remember the as value. The partition by will keep the keys going to the same topic, which may allow those segments to be smaller because say in my scenario, all orders by stores went to the same segment. Maybe that will allow me to have more rollups. Entire demonstrations available to you from this link. It is actually my development environment, Kafka local. I have Druid in there, I have Kafka, I have Connect, I have Superset, I have Flink, I have Oracle. You have to do your work to get the Oracle image because there's not one that you can provide. It's all available for you. And then there's a demo EOS that runs through everything that I went through today if you're interested in. Feel free to reach out. Here's my contact information, my email, my LinkedIn, and my Twitter. And that's it. And question time.
Well, thank you very much. Thank you very much, Neil, for the great talk. And right now, I don't see any questions in the Q&A tab or the session tab. So if anybody has anything they'd like to ask Neil around exactly one semantics or Kafka or that very cool project, which I am definitely going to go check out after this session. So thank you for that. I need to figure out how to screenshot things and actually copy and paste them into links. So does anybody have any questions for Neil? Oh, we do have one. Great. Where can you get the slides? There you go. That answers that question.
Well, I think the slides, will Druid Summit make the slides available? I know you'll make the videos available. Will you make the slides available, or do you prefer that the presenters do that? I'll probably share it, but I'm not, it may be, I'll probably share it on one of my social medias once this is done. And then I guess
that's probably the best place to go. So that's a very good question. I should know the answer to that, and I don't. Mike has a suggestion for everybody.
He's giving
where to find the slides.
We'll make sure that we make it available. I'm sure the summit will make it available. I know you'll make the videos available if I read that correctly.
Definitely make the videos available. I don't think we're making the slides available, so okay. I would follow Mike's link there.
Perfect. And I should just point out, I love talking Kafka. I love talking Druid now too. Reach out and have questions around it, I usually will respond pretty quickly. It's been fun getting to work with these. I was talking to Rachel earlier about how natural it feels that Druid is. Kafka is where I came from. Druid's where I'm at now. And it feels like a natural pairing. And as I've learned it more, I feel that they fit well together.
Yeah, we definitely see at this point, most implementations that I get the honor of looking at are using Kafka. I'm not saying that the native batch or the Hadoop ingestion isn't still, well utilized, but like you said, it's definitely it definitely makes life a lot easier, I think, on both sides.
Yes. Thanks,
All right,
Robert.
well, we'll let our attendees head on out to the next session. We have some interesting talks from App Dynamics on challenges in building highly scalable metrics platform for observability. I've had a sneak peek on that one, and it is excellent. Bonnie's a great presenter. The Keeping Druid Honest, A Journey of Testing Druid by Andy and Savitha, who work for Imply. So they do spend a lot of time testing Druid. So they've got some really good tips and tricks there. Migrating their ML Insights platform to Druid from Y Labs. And that's up for the next session, which starts in 14 minutes. So, grab yourself some beverage, hot, cold, and some snacks. Oh, well, we do actually have a question for you, Neil. How was the test setup to make 1,000 rows sufficient for the test?
Efficient for the test. I'm not quite sure. Efficiency.
Sufficient. Sorry, my fault.
Sufficient.
Yeah.
Well, there was. Let me go back to it to make sure you can see the numbers. Of course, if I could find where I'm going, the orders was unbounded. I think I ended up creating like 1 million orders. I created just 1,000 users and 100 stores. So if I would go to the demo, if I go into my data folder, data gen orders, basically data gen provides a nice tool to generate randomness or controlled randomness, for lack of a better word. So I tell it to create orders ever increasing from 0. I tell it to create order using regular expression, stores from 00 to 99, users from 000 to 999, and then random quantities and so on. So the order part was not 1,000. The order was actually, I created up to 10 million, if I got my comma insertion correctly, or 10 million or 100 orders as I was running through this. So it wasn't just 1,000. So I think it's just confusion or me rapidly going through a slide where I commented on the number of users, not the number of orders. And again, check out the demo there if you're interested. And if you see an error or you see something confusing, please let me know. I try to keep it current with all the demos that I'm putting together for various presentations. Well, I'm not seeing any other questions myself. So at this point, I will conclude this. And thank you everyone for attending. Enjoy the rest of Druid Summit.
Much, Neil. Thanks everybody for coming.